Welcome to Science Access. In today's class, I'll be talking about Boyle's law. If you know you are new to this channel, please kindly subscribe to support us. Now, Boyle's law states that the pressure exerted by a given mass of a gas is inversely proportional to the volume occupied, provided the temperature is constant. Now, let's not get ourselves confused. We have just few terms here. Number one is pressure, mass, then volume and temperature. Now, two of these quantities or parameters are constant. Now, a given mass, the mass is fixed. Then the temperature is also constant. So, two of these parameters are constant. Mass is constant and temperature is constant. Now, the pressure is inversely proportional. That means if the mass is constant and the temperature is constant, the pressure is inversely proportional to the volume. Inversely proportional means that if the pressure is increasing, the volume is actually decreasing. And if the volume is increasing, the pressure is actually what? Decreasing. So, given that the mass is constant, the temperature is constant, the pressure is actually inversely proportional to the temperature. Sorry, to the volume. Or the pressure or the volume is inversely proportional to the pressure. Now, note this fact. Now, P is inversely, this is the proportionality sign. So, it's inversely proportional, that's the reason why it's 1 all over V. So, P is inversely proportional to what? The volume. Because it's 1 all over V, that means it's inversely proportional. Assuming it's directly proportional, it will now be P, then V. So, note that direct proportionality will mean P, V. But in this case, P is actually inversely proportional to V. Now we can introduce the constant sign. In that case, P equal to K all over V. Because you introduce the constant of proportionality sign or the constant sign, this proportionality sign will now change to equal to sign. Then we can cross multiply. K times 1 is K. That's what we have here. Then P times V is PV. So we now have K is equals to PV. So this is actually the formula. In the situation where we have 2 volume and 2 pressure, so we now have P1, V1 is equals to P2, V2. So this is how this formula actually originates. That's the simple explanation for this formula. Now let's explain in a simple term how pressure increases and volume will decrease. Now take a look at this little container. Now, the pressure is large. We have how many atoms of gas in this place? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, the pressure, the volume in this place, sorry, is large and the pressure seems to be low. How do I know that the pressure is low? These gases, the atoms are spaced out. So, when we talk about pressure, it means how fast they are colliding with themselves and with the wall of their container. So, because the volume is large, they will not collide with themselves as fast as it should be when the volume is low. So note that because the volume is large, the rate of collision will be low. Now let's assume that we reduce the volume. These atoms of gas will become closer to each other, so their rate of collision will become what? Higher, and they will also be colliding with the wall of their container. So the pressure will increase. So you realize that as the volume is decreasing, the pressure is actually increasing. What about if you now decrease the volume further? If you decrease the volume further, and in this case the volume is so small, the pressure will increase greatly because the atom of gases are now so close to each other and they will now be colliding among themselves and with the wall of their container. So this place will now have great pressure or high pressure. So we realize that as the volume is decreasing, the pressure is actually what? Increasing. Now we can represent this in another format. You realize that here the volume, the P, which represents the pressure, is actually big or high, while the volume is low. Now, why the size of this P or the pressure is reducing, this one is actually smaller than this, then the V is actually increasing. So, P is reducing, V is what? Increasing. And P is what? Reduced further, V actually what? Increase. So, when you have large volume, the pressure is actually small. Or when you have great what? Or high amount of pressure, the volume is small. Under the condition that the temperature and the mass is actually what? Constant. Now let's take a look at the graphical representation of this. Now, take a look at the graphical representation. You realize that in this place, here, at this particular point, the volume is very high, but the pressure is low. Now, as the volume is actually decreasing, the pressure is what? Increasing. So this is a graphical representation of Boyle's law. You can also decide to change the format. In this place, you have volume, you have pressure here, but you can also decide to put pressure here and volume here. You still have the same kind of graph, because it's actually indicating that here the pressure is high and here the volume is what? Low. You can see it here, volume low. But as the pressure is going down here, the volume is actually what? Increasing. It's moving towards this direction. Now, there are some cases where you have a straight line. It's only because you are having P's against 1 all over volume. In this case, remember, 1 all over V is what? The inverse proportionality, and you have a straight line graph. And here, if you decide to interchange it, you also have a straight line graph. If you are having 1 all over any of the parameter, you have a straight line graph. So please know this. It's a very simple concept. All right, let's take a question. Let's take a calculation question on this. Assuming the volume of a given of oxygen at a pressure of 0.5 atmosphere is 700 centimeter cube. Calculate the volume when the pressure is increased to this at constant temperature. Now remember our formula. P1 V1 is equals to P2 V2. Remember, we are given 2 pressure and 2 what? Volume. And temperature is actually what? Constant. So you use your formula P1 V1 equals to P2 V2. All right. So P1, in this case, let's go to the, assuming the volume of a given of oxygen at pressure, this is our P1, is this. So this is our V1. This is the P1, the first pressure, and this is the V1, the first volume. So P1 is 0.7. You can decide to put the units, no problem. V1 is 700. You can also decide to put the unit. Now let's talk about the P2. Calculate the volume. So you are now asked to calculate the V2. So you put your V2, you don't know that. Calculate the volume when the pressure is increased to 1.8 atmosphere. Now that means P2 is 1.8. You put your formula. This is your formula. You put it here. Now you want to calculate for the V2. How do you now? You have to make V2 the subject of formula. How do you make V2 stay on its own? You divide both sides by P2. The reason why you are dividing both sides by P2 is because you want the P2 at the bottom of this to cancel out this, so that only V2 will stay on its own. So we'll now divide both sides by P2, and this will actually cancel out this. So we now have V2 is equal to this, which we put down here. It's the same thing as V2 is equal to this, so you can rearrange it. V2 is equal to this, or this is equal to this, the same thing. So if you have V2 is equal to P1 V1 all over P2. What is P1? From our formula, P1 is 0.7. You put it there. V1 is 700. You put it there. Then P2 is 1.8. You put it there. So you now have 0.7 times 700 all over 1.8. Now we can go further. Use 0.7 to multiply 700. You have 490 all over 1.8. And if you carry out your division, you have 272 centimeter cube. So this is our answer. This is just an introductory class to Boyle's law. In my part 2 of the series, I will solve more questions on Boyle's law. Thank you for watching.